In this video, we're looking at coordinate geometry, and we have the specific objectives here, and you can read through them. Pause the video, read through them. Now, coordinate geometry, also known as analytical geometry, has various applications in real life, and here we have some of them. Again, you can pause the video and look at these. Now, what about being a photographer? Of course, coordinate geometries are even applicable in this field, and you can read these notes as well. Now, these are the formulae that you would want to know by heart. Given 2 points A and B, and you have the coordinates of these 2 points, then you can find the gradient, the length of the line. You can find the coordinates of a midpoint between two points again, and you can also find the equation in the intercept form. Again, you can read through these notes as well. Alright, so this video is made with the idea that you'd have covered this content already. Also, you need to have some knowledge of parallel and perpendicular lines. When two lines are parallel, it means that they have the same gradient. So if you have one line AB, and this is this equation, and you have another line PQ, this is also the equation, then you should know that the gradients, that is the M, the gradients must be equal. So if M1, that is the gradient of line AB, is equal to U over V, then both gradients will be equal to U over V, because gradients of two lines that are parallel are equal. Also, what about when the lines are perpendicular? Well, if the lines are perpendicular, that is, line AB is perpendicular to line PQ, then when you multiply their gradients, you should get -1. That is, the gradients are negative reciprocal of each other. So if M1 is equal to U over V, then M2, that is the gradient of the second line, will be the negative of this one, so that'll be negative. Reciprocal means we're going to upturn the fraction of this one. So let's suppose that the gradient of one line is 2. Then the gradient of the other line will be the negative reciprocal. Since this is positive, this one will be negative. And since this one is 2, the other one reciprocated will be a half. Because we know that 2 is really 2 over 1. And so when you reciprocate it, you'll get 1 over 2. This is positive, this is negative. What about if the gradient of one is, let's suppose it's -3. Then the gradient of the other will be, since one is negative, the other one will be positive. Reciprocating 3 will be 1/3, because 3 is 3 over 1. And so forth. So let's carry on with the lesson. We're going to look at a real example now, where we have a straight line passing through the y-axis at P and the x-axis at Q. And we're asked to determine the coordinates of P. So what are the coordinates of P? Now, if the straight line crosses the y-axis at P, then this is called the y-intercept point. And so since it's a point, it has 2 coordinates. Now, if we start at the origin, let's start at the origin, and we want to get to the intercept here at P, we would not need to move left or right. So we'll stay at 0 on the x-axis. So that means for the point P, the x-coordinate is 0. Since I will not move to the left or right, I'll stay at 0 on the x-axis, and I move 2 units up. And since I'm going upwards, I'm on the y-axis, and I'll move 2 units upwards, so that's going to be 2 for the y-coordinate. In other words, if you look at point P here, to find the x location, you can go down to the x-axis, and since we hit the origin, the x-coordinate is 0. And since we are already at 2 on the y-axis, the y-coordinate is 2. And for the point Q here, starting at the origin, if you want to get to the point Q, we need to move 2 units, well, not 2, but 3 units to the right. So that's +3. Positive 3 indicates we're moving 3 units to the right on the x-axis. All right, now positive 3 in terms of the first coordinate. The first coordinate is always the x-coordinate, the first movement that you'll make. If you do not make a movement left or right, then you're saying that the x-coordinate will be 0, as in the case of P. But since we move to the right for the point Q, then the x-coordinate is going to be a positive. And we move 3 units to the right, so it's a positive 3. Now, since we're already at Q, moving 3 units to the right, then y will be 0. Why is that? Because we do not have to move up or down in order to get to Q. So the y coordinate is simply 0. So quickly, let's make this point that any point found on the y-axis, as in the case of P, x will be 0. And any point found on the x-axis, y will be 0, as in the case of Q. All right, so now I label these points. Let's call this x1, y1, indicating the first point P, or the first x-coordinate and first y-coordinate. Now for the point Q, we have the second x-coordinate and the second y-coordinate. To differentiate between the first and the second, we use 1s and 2s. If you want to find the length of the line segment PQ, then we'll use these straight lines to the left and right of PQ, indicating that this is the length of PQ, and this is the formula. So it's the Pythagorean theorem, which, if you want to find the length of the hypotenuse, is the square root of the sum of the squares of the x and y. Now, in this case, we want to put the difference in x's and then the difference in the y's. So you got to memorize this formula. Okay, so now what we're going to do, we're going to enter those values. Now I would have labeled the points P and Q, and using this formula we can substitute. x2 is going to be 3 minus x1, which is 0. I'm going to have those in brackets, squared. y2 is 0 minus y1 is 2 squared. And this will give us 3 minus 0 is simply 3 squared, plus 0 minus 2, that's negative 2 squared. And this will give us 3 squared is 3 times 3, which is 9. Negative 2 squared to be squared is negative 2 times negative 2, which is positive 4. Once you're squaring a quantity, the quantity inside the bracket, once it's negative, it will still remain negative in terms of it will remain negative, but when you square it, it will become positive, because negative times negative is positive. Now, simplifying underneath the square root symbol, we have 9 plus 4, which is 13, which gives us 3.6055, etc. Let's say we want 3 significant figure. 3 is the first significant figure, that is the first non-zero digit. So 1, 2, 3. 0 in between non-zero digits are significant. So this 0 falls between 2 non-zero digits, so it's significant. And so we can count 1, 2, 3. We want only these guys here. So when we're chopping off the rest, we're going to check in terms of the first digit. And since the first digit is 5, we add 1 to the previous digit. So 5, 6, 7, 8, or 9. If that's the first digit of those we're chopping off, we're going to add 1 to the previous. And so rounding this off, adding 1 to 0, that will be a 1 here. So that's 3.61 units. We put units to indicate that it's a length, a measurement of a length, right? Could be centimeters, could be meters. We don't know. So we just simply use the term units here. All right. And that's it. But we can put corrected to 3 sig fig. All right, meaning 3 significant figures. If you want a midpoint now, a midpoint is the midpoint between P and Q. What is the midpoint between P and Q? Let me just put this here quickly. This one is 3, 0. What is the midpoint? The midpoint will be somewhere in between P and Q. Now let's see we do it algebraically. Here's the formula. Now the midpoint, we use capital M for midpoint. And since a point, it has two coordinates, the X and Y coordinate. And it's really the average of the X coordinates as well as the average of the Y coordinates. And we want to find in the average, what do? We add the two values and divide by 2. If it's 2 values, right, we want to find the average of. If it's 3 values, we add the 3 values and divide by 3. But in this case, since we find the average of 2 coordinates, we add the 2 coordinates and divide by 2. And let's substitute. X2 is 3. X1 is 0. Divided by 2. Y2 is 0. Y1 is 2. Right? We're using these points, right? And divide by 2. So we're going to get 3 plus 0 is 3. Divided by 2 is 3 over 2. 0 plus 2 is 2. Divided by 2. And this will give us 2 goes into 3 once. Remainder 1 over 2. Once you see the top is a bigger number than the bottom, in other words, 3 is being divided by 2. Okay, so our 3 is divided into 2 parts. And they're going to get 1.5 each, correct? So once the bottom number is smaller, then it can enter the bigger number on top. So we call this a top-heavy fraction or improper fraction. Now 2 goes into 2 once. That will be the midpoint. So the X coordinate of the midpoint, as we can see here, the X is the first coordinate always of a point, is 1.5. So we go on the X-axis and we find 1.5, and that will be right here. Right? 1.5 will be between 1 and 2, directly between, and we can go up and see where that hits the graph itself, which is right here. If we check this point, which is the midpoint, we check the Y coordinate going across to the Y axis, it hits it at 1. So we see that it's 1.5 on the X axis and it's 1 on the Y axis. So that's the midpoint. Okay, so now let's look at the other questions. Now we want to find the gradient of the line. And let's look at that quickly. So to find the gradient, let's put back the coordinates of P, 0, 2. And for the point Q, we have 3, 0. And of course, we label these X, Y's, because those are the coordinates. These are the 1s and these are the 2s. Okay, so we have x1, y1, x2, y2. And the gradient formula is y2 minus y1 over x2 minus x1. Now y2 here is the second y coordinate from the point Q would be 0. The first y coordinate from the point P is 2. The second x coordinate from the point Q is 3. And the first x coordinate from the point P is 0. Now 0 minus 2, that's negative 2. And 3 minus 0, that's 3. So the gradient is negative 2/3. Okay, so the gradient of this line, PQ, is negative 2/3. All right, another way we could find this is using the formula called rise over run. So the difference in the y's is a rise. So if we look at P and Q, and we form a right angle underneath it, then this is called a rise. From the origin to P, that's the rise. You can see that's the vertical rise. And the horizontal shift from the origin to Q, we call that the run. So the rise from the origin to P, that will be 2 units. And the run, that will be 3 units. Now, if you want to find the gradient, you're going to put rise over run. So the gradient, M, is common letter M, by the way. rise over run. Now since the graph is sloping downwards, or it's a left hand diagonal, if you look at someone facing this plane, right hand diagonal, left hand diagonal. Right hand diagonal indicates positive gradient, left hand diagonal indicates a negative gradient. But we can see this orientation of this line is similar to the left hand, and so it's a negative gradient. So it's going to be negative gradient, and remember, say it's rise, so it's going to negative 2 over the run, which is 3. So this is another way of doing it graphically. Now let's look at the next question, which is the equation of the line PQ in the slope-intercept form. Slope-intercept form is y equal mx plus c. And so two things we need. We need the gradient, and we also need the y-intercept c. Now what is the gradient? Well, we just found the gradient, and it's negative 2/3. And c is where the graph cuts the y-axis, and the graph cuts the y-axis at 2. And so that's going to be positive 2. If you want to find it algebraically, let's assume that you weren't given the graph, then you could have done that as well. You could just simply, let's look at it. Let's say we put back the c here. You could replace the y and the x with any one of these points on the line. Let's suppose we use the point Q, which has coordinates 2, 3, 0. That means the x is 3 and the y is 0. So replace y here with 0. Replace x here with 3. And then we'll cancel, right? Negative 2/3 of 3. 3 into 3 goes once, and 3 into 3 goes once. We cancel a denominator with a numerator, because 3 is really 3 over 1. Now this is going to be simplified as negative 2, since 3 cancel 3, so you're left with 1 times negative 2 is negative 2. And then you're going to add 2 to both sides to get rid of this 2 here, so that becomes c equals positive 2. Another way you could look at it is if you were to transpose this negative 2 to the other side, then you'll have 0 plus 2. And now c will be isolated on this side. And 0 plus 2 is actually 2. So c is equal to 2. And so now we can actually rewrite the equation. Y equals the gradient, which we found, negative 2/3, x, and the c value is positive 2. Okay, so now we figured out that this is it. Again, we could have simply taken the y-intercept from the graph. Now the equation of the line PQ in the slope-intercept form. So this is the slope-intercept form. X over the x-intercept, y divided by the y-intercept equal 1. Always equal 1. This is the form. Now, so what we got to do now is simply to replace a and c, and that will be it. So it'd be x over the x-intercept. Where does the graph cut the x-axis? That's the x-intercept. That's 3. Where does the graph cut the y-intercept? At 2. On the y-axis. Equal 1, and that's it. And if we're given this form, we know we can write the gradient from it, right? The gradient of this, used from this form, is negative c over a. So it's the negative of c. What is c? C is 2. And what is a? 3. So we found the gradient another way. All right, but we don't need to go through that since we already found it already. But this is the equation that we're looking for. All right, next, let's look at the equation of the line ST that is parallel to PQ. So we have another line now, which is ST, that's going to be parallel to the line PQ. All right, so we're told that this line ST passes through the origin. So we know that's not PQ, because PQ doesn't pass through the origin. But look at the subject, the equation of the line ST. What is it? It is parallel to PQ, and it passes through the origin. Now we have to recall that the origin is where the y-axis and the x-axis intersect. So it's going to be right here. That's the origin right here. And the origin has the x-coordinate of 0 and y-coordinate of 0. So the origin has coordinates 0, 0, because the origin is a point. Has an x-coordinate and a y-coordinate. Okay, so now let's go back a bit and double check something here. So we found the equation of the line PQ, correct? Which is y equals negative 2/3 x plus 2. y equals negative 2/3 x plus 2. So always good practice to put it on the line that we have, right? So let's write it over here. Y equals negative 2/3 x plus 2. Okay, and here we have another line now, ST, that's going to be parallel to PQ, the line PQ, and it passes through the origin. So if it's going to be parallel to this line PQ, then it's going to be sloping the same way. But notice that it says it passed through the origin, so it's going to look something similar to the line PQ, just that it is passing through the origin. And they will never meet because they're parallel. Right, so this will be line ST. All right, so let's have a better line. Okay, so this is our line ST, and they want the equation of that line. So the equation of the line ST, let's have it in the slope intercept form. What we want its gradient, and we want where it cuts the y-axis. Now, if two lines are parallel, it means they have the same gradient. And the gradient of the line PQ is negative 2/3. Now, the gradient of this line is also negative 2/3. Why is that? Because two lines that are parallel have the same steepness, and gradient means slope, the slope of the line. So they both have the same gradient. But now, they obviously cut the y-axis at different points. This line PQ cuts it at 2, the y equals 2. And this line ST cuts it at the origin at 0. Right, y equals 0 there. So, but do we need to have plus 0? With adding 0 to any quantity will give you back that same quantity. So we do not need to put the plus 0. Okay, so it's in the form of y equal mx plus c. It's just that our c value is 0, and so we do not need to put it. It's understood to be that. So if you have another line, y equals 5x, for instance, and this is the equation of a straight line still, it's just that what? It's just that the gradient is actually 5 in this case, and the y-intercept c, it would be plus 0. All right, that means this line passes through the origin. So if you're not seeing the constant after the mx term, just know that the c value is 0. Okay, so once we understand that, we're good. Now, so this is the answer that we're looking for the line ST. So the line ST has an equation, y equals negative 2/3 x. Do we need to put the plus 0? Nah, we don't. It's understood to passing through the origin. Now let's look at the next question. I'm going to just write these back here quickly. And this one is y equals the same negative 2/3 x plus 0, as in passing through the origin, but we don't need to put the plus 0. Going back to the question now, we're looking at G. We want to determine the equation of the line JK. So this is going to be a new line. This is the line ST. Let's put S somewhere here and T somewhere else as well, right? The line ST. So we know that this is the line ST. Okay, we weren't told where S is or where T is on this line, but it's fine. All right. The equation of the line JK. Want to determine that equation of the line JK that is perpendicular to the line PQ and passes through the origin. No, and passes through the point 2, 1. So we know the line PQ has the equation y equals negative 2/3 x plus 2. And here we have another line JK, and we're told that its gradient, well, we're told that that line JK is perpendicular to PQ. That means PQ meet JK at a 90 degrees angle. This means perpendicular. All right, so the two lines are not parallel, but they're perpendicular. And perpendicular lines meet at 90 degrees, correct? But what we know about perpendicular lines, though? Well, in terms of coordinate geometry, their gradients are negative reciprocal of each other. So the gradient of PQ is negative 2/3. That's the gradient of PQ. The gradient of JK will be the negative reciprocal of this one. A negative reciprocal meaning if this one is negative, then the gradient of JK would be what? Since the one is negative, it will be positive gradient. And since one is 2/3, then the other one would be 3/2. All right, and that's what we mean by reciprocal. We flip the 2/3 and get 3/2. So 2/3 flipped. The 3 goes on top, the 2 goes at the bottom. So that would be 3/2. So we can replace, so this will be the gradient of JK. So if, in the form of y equal mx plus c, we can rewrite the gradient being 3/2 x, and the c value. What will be the c value? Well, we do not know exactly where JK cuts the y-axis. We don't. We're not told that here. But we do know what? We do know that the line JK passes through the point 2, 1. So we can substitute the coordinates of that point 2, 1 into the equation JK. Right? So we can replace the x and y with 2 and 1 respectively. So y is 1 here, and the x will be 2. And then we can simplify either side. No, simplifying the right hand side, we have 2 into 2 goes once, and 2 into 2 goes once. So this can be 1 times 3, which is 3, simplifying this. Now we're going to subtract 3 from both sides. Subtracting 3 from this side will isolate the c, and we subtract 3 from the left hand side. And so we have c equals 1 minus 3, which would be negative 2. Now think about it. Use number line to help you. If you're at 1 and you subtract 2, well, subtract 3, 1, subtract 3, you're going to get 1, 2, 3. Subtracting 3, you're going to get negative 2. Okay? All right. So c is equal to negative 2. So now JK, the equation for JK, we can now replace, go back to the original form, y equal mx plus c. Replace the m with the gradient of JK. Replace the c with the y-intercept of JK, which is negative 2. And so this is the equation for the perpendicular line JK. Now, let's just look at this. Let's look at this on the Cartesian plane, or coordinate plane. So here we're seeing JK passing through the point 2, 1. All right. So this is the point 2, 1, meaning it's at 2 on the x-axis and 1 on the y-axis. And it also passes, that same line JK passes through the point 0, negative 2. In other words, it cuts the y-axis at negative 2. So we draw a line through the point 2, 1, and where it cuts the y-axis at negative 2, we're seeing that this will be the line y equals negative 2/3 x minus 2. So that completes the questions, all right, that we were asked to complete from A to G. Any questions? All right, so let's look at another problem.